Right, so we're going to continue talking here about how to organize data. So this whole chapter is about organizing information and understanding it so we can better use it to help people and better use it to glorify God. So last time we talked about the first type of way to organize data in a diagram, which is the box and whisker plot. Now we're going to talk about two more diagrams. The first one is called a stem and leaf plot. So when do I use a stem and leaf plot? I use it when I have one large group of numbers. So just like with my box and whisker plot, if I have one large group of numbers, I'm going to use the stem and leaf plot. So the stem and leaf plot, let's say I have this group of numbers right here. What I'm going to do is my left-hand side is my stem, and my right-hand side is my leaf. So just like on a tree, I have stems or branches, and then on that stem I have a whole bunch of leaves that go off them. And that's the same idea here. So for the leaf is always just going to be the last digit of each number. And then the stem is going to be the rest. So if I only have one other digit, there's going to be one there. If I have more than one other digit, then it's going to be the rest. So basically, in this case, since all of these numbers have two digits, basically my stem is going to be my tens place, and then my leaf is going to be my ones place. So what I'm going to do is I'm going to go through and I'm going to find out how many of each kind I have. So how many that I have that are in the tens, how many are in the 20s, how many in the 30s, how many in the 40s, and so on. So I have one here that is in the tens, 16. So I'm going to write 1 for those that are in the tens. And then I'm going to write on the right side of this dark line, 6. That's the only one that I have in the tens, so that's all I'm going to write. Next, I have 29, and I have two 29s. So I'm going to write 2 here for my 20s, and then over here I'm going to write 2 9s. Since I have two 29s, I only write the 2 once, so all of my 20s are going to be over here, and then I'm going to write what I have in my ones place. Next, I have 30, 35, and 39. So I'm going to write 3 just once for all of my 30s. And then over here, I'm going to write which 30s I have. So I have 30, I have 35, and I have 39. So I write the ones over here, the last digit over here, and then just once, the first one. Then I have 40, 44, and 46. So again, I'm just going to write 4 once. I have 40, so that's a 0. 44, so the one that is a 4, and then 46, so it's a 6. Again, make sure you do this in order from least to greatest. Then I have my 50s. So I have 50 and then 51. So we're going to do 0 for 50 and then 1 for 51. 60s, I don't have any 60s. 70s, all I have is the 0. Now, with a stem and leaf plot, you also want to do a key. So at the bottom, I'm going to do a key. And the key is very simple. All I'm going to do for the key is write something like this. 1 vertical line 6 means 16. So anytime you do a stem and leaf plot, make sure you have a key. All you can do is you're just going to choose one of your stems. So I'm just going to choose the 1, 6, and then show that what that means is 16. I could have chosen 2, 9, and said that means 29. Or 3, 5, and said that means 35. It doesn't matter. Now sometimes your stem and leaf might have 3 digits instead of 2 digits. So let me quickly show you how you would do it if it only had, if it had 3 digits. So let's say my group of numbers here, let me write a different group of numbers. I'm going to have a different stem and leaf plot here. So let's say, for example, I had 150, 151, 169, 173, 175, and 193. Okay, so notice this time I have 3 digits instead of just 2. So remember, my leaf is only the last digit. That means my stem is going to have 2 digits. So for example, I have 150, so my stem is going to be all of my 150s. So I have 150, so I put a 0, and then 151, so I put a 1. I have 169, so my stem is going to be all my 160s. And then I just have 1, which is 169, so I put a 9. I have 173, so I'm going to do my 170s. So I have a 3, 173, and 175. And then I don't have any 180s. I have 190, which is 193. Again, I'm going to put my key. So this time for my key, I'm just going to choose the first one again. So I'm going to do 1, 5, vertical line, 0, means 150. So that's my stem and leaf plots. The key thing is the one on the right, that's going to be the last digit. On the left is whatever other digits I have. On the left, I'm only going to write 1 for every 10. And on the right, I'm going to write which last digits do I have in that group. So this will be all my 150s, all my 160s, all my 170s, and so on. And then make sure you include the key so anyone reading it can understand what that's saying. So I'm going to use that 7-leaf plot if I have one large group of numbers. But what happens if I have two different groups of numbers? So let's say this is just the group of numbers of all of the people that attended church each Sunday over the last year. So it's the same type of numbers every time. But what if I have two groups of numbers? Let's say, for example, I want to compare in a city people's heights with their weight. So that I want to see a correlation. I want to see if as people's height go up, does their weight go up or does their weight go down? So I want to compare two different types of information, height and weight. I might want to compare things like cost of food and the amount of food I get. Or I might want to compare two things like a person in sports, their number of shots they take compared to their assists. And there's a statistic in basketball that compares assists to turnovers. You might want to compare in a cake how many cups of flour I put compared to how many cookies I get out. So I'm comparing two different types of things. When I compare two different types of things, I want to use what's called a scatter plot. So the stem and leaf is only when I'm doing one thing. Number of people that went to church. The number of people in each city in the United States. Just one type of thing. My scatter plot I'm going to use to compare two types of things. So I'm always going to have two numbers that go together. So this is going to be just like we did before with an ordered pair. Remember we have the x and the y and those two numbers go together. So remember I put that on a coordinate plane. If I have 2, 3, I go over 2 and up 3 and I do that. Now remember with my coordinate plane I have 4 different quadrants. I have my first quadrant, my second quadrant, my third quadrant, and my fourth quadrant. Now normally when I'm talking about information, the number of cookies or the number of people or the height or the weight, I'm not going to deal with negative numbers. So since I'm not dealing with negative numbers, really all I need is my first quadrant. I don't need these other 3 quadrants because all of those have negatives. So when I do my scatter plot, I'm only going to draw my first quadrant. So it's just going to look like an L because it's just going to be this positive part of my coordinate plane. And I'm always going to have 2 groups of numbers. So for example, here I have my height and here I have my weight. And each group of numbers is always going to have pairs. So notice the 65 goes with the 160, the 63 goes with the 145, the 72 goes with the 180, just like my pair of numbers here. So when I'm going to graph this, now notice these numbers are very, very big. So if I started with 0 and 1, 2, 3, 4, 5, it would take me forever to get all the way up to 65 and 160. So I'm going to choose to start, instead of starting at 0, 0, I'm going to start with my smallest number. So in this case, the smallest number, I don't have them all listed here. You can see this in your book, the whole thing in your book on page 400. But the smallest number is 120 for my weight and 61 for my height. So I'm going to start, instead of starting at 0, 0, I'm going to start there. That way I don't have to write out all the rest of those numbers. And you can start with your smallest pair of numbers instead of starting at 0, 0. Also, you can see here that on the bottom, I've done it one at a time. 61, 62, 63, since all these numbers are pretty close together. But here I've done them by every 10, since these numbers are a lot farther apart. So you can space them however you want to space them, whatever makes sense and whatever is easiest for you. Finally, notice I put my weights up and down. So my weight numbers are up and down. That would be the y-axis. And then my height numbers are left and right. That would be my x-axis. So make sure you choose one to be the x and then the other one to be the y. So since my height is my x, my weight is my y, my first pair is 65 and 160. So I'm going to start with my height, and I'm going to go over to 65, which is right here. Then the weight that goes with that height is 160. So once I get to 65, I'm going to go up on the left to 160. So that point is right there. So I went on the height first to 65, then I went up from that point to 160, just like I would do on a normal graph. My second pair is 63 and 145, so I'm going to go here to 63, and then up to 145, which is right here, and I'm going to put a big dot right there. Then I have 72 and 180, so I'm going to go over here to 172, up here to 180. Then I have 64 and 150, which is right here. Then I have 70 and 220, which is right here. Then I have 70 and 180, which is right here. Now, if I were to keep doing this, I would get a lot more points here, but you can see a correlation. And the correlation is that overall, you can see going from left to right, the dots get higher. Now, you're not going to connect the dots. So don't connect the dots like you would do for a line graph. Just leave the dots. But looking at the dots, you can see from left to right, they are overall, not always, but overall they're going up. So if they're overall going up, we say that's a positive correlation. What that means is that normally, as someone gets taller, as their height goes up, their weight also goes up. That's a positive correlation. On the other hand, if you look in your book, I'm not going to write this on the board, page 401, they have a relationship between the hours of TV you watch and your GPA. So as you go left to right, it talks about how many hours you watch, and then bottom to top, it talks about what your GPA is. So you can see the dots there, they're actually going to go like this overall. They're going to go down. That's a negative correlation. So if from left to right they go up, that's positive. If left to right they go down, that's negative. What that means, obviously, is the more hours of TV I watch, the lower my GPA goes. So there was a negative correlation between hours of TV watched and GPA. Now, sometimes there's not going to be any correlation. If there are just dots everywhere, or if the dots sometimes go up and then down and up and down, then you would just put there is neither negative nor positive. There's not really a correlation. But if you can see that overall it seems to be going up, that's positive. If it's overall going down, that's negative, and that's what we call a scatter plot.